So it is saying the diagram shows a right angled triangle ABC. ABC. This is a right angled triangle because here it's making 90 degrees. That's what this means. So BC is produced to D here. So BC reaches this far end, D. AC, this is 13, and cos BAC is 12 over 13, cos BAC. Note that the angle is at A, so cos this angle is equal to 12 over 13. Now, this is trig. They're asking us to find the value of tan ACD, this angle. So, you need to use SOHCAHTOA. This is what you use. When you are dealing with sine, this is equal to opposite over hypotenuse. Cos is equal to adjacent over hypotenuse. Tan is equal to opposite over adjacent. Now, this is what it means. In this case, they've given us cos. So, cos is equal to, this is adjacent. So, we say cos theta is equal to adjacent over hypotenuse. So, when you are looking for this theta, in this case cos BAC, this angle. So this angle, the opposite side of this is the side that it's facing. So this is facing this side. It's more like if this is an eye, it's looking at this. So this is the opposite side of this. Okay? And the hypotenuse is the longest side. This is the longest side, meaning this is the adjacent. So these are the three parts that you have: the opposite, the hypotenuse, and the adjacent. So for cos, when you are looking for cos, the top is the adjacent. So this is cos this. What is the adjacent? I'm saying this is the opposite, the hypotenuse. This is the adjacent. The adjacent is on top. So for this one, it's 12 over 13. So the adjacent is what? Is 12. That's what it means. Then the hypotenuse is what? 13. And we understand the hypotenuse is the longest side. No wonder here it's 13. So if this is the opposite, this is the hypotenuse. This is the adjacent, which is on top. Meaning the number on top, 12, is the adjacent. Meaning here it's 12. You get that concept? That's how it is. Then, what about this? Because we are going to need this side also. From this side now we can find using Pythagoras theorem, because Pythagoras says this longest side, 13 square, is equal to the square of these shorter ones. So the hypotenuse, the longest side, when you square it, it is equal to 12 squared plus this side BC squared. So this is okay, to simplify it, we can say 13 squared, we take this 12, it will be minus 12 squared. If you want, you can, it's one and the same. If you go the other way, it's equal to, will remain with BC squared here. So 13 squared is 169. 12 squared is 144. These two numbers are very important in paper 1. You need to know 13 squared is 169 and 12 squared is what? Is 144. So 169 minus 144. So we'll say 169 minus 144 is equal to BC squared. 169 minus 144 is 25, which is equal to B squared. Therefore, if we come this side, we can say BC squared is equal to 25. For us to get rid of this, we introduce the square root. So we are going to say BC is equal to 5. In this case, we'll go with positive only, even if it's the square root, because we can't have a negative length. Length can't be negative. So the answer will be positive or negative 5. Then you go with positive 5. Meaning BC is what? Is 5 centimeters. So that's the case. Now the question is asking you to do what? Find the value of tan ACD. So tan ACD, the angle is at C. is equal to, you get back to SOHCAHTOA, this is tan. It is equal to opposite over adjacent. Opposite over adjacent. So, tan ACD. ACD. This is the angle they are looking for. So, tan this, the opposite of this, unless we draw this line like this, then this will be the opposite. But when you draw a line like this, you see that this is longest side and it becomes the hypotenuse. So what we do for this case, you know that this angle ACD, this is an exterior angle. The angle which is not inside, which is outside. This is outside, right? These angles are inside and this is an exterior angle. It is outside. If you want to find this tan, what the concept you use, because this question usually comes, they'll bring this triangle and it will be like this. They will ask you this, what? This outside angle. You consider the angle that is immediately inside, the interior of this, it's this one. That's the one you will find instead. Then you change the sign. So instead of finding tan this, the one they are asking, ACD. ACD, you see that this is the exterior angle and it will not work here. You get the interior, which is this, you find it and this and you change the sign. So instead of finding this, we'll find tan this. So when you look at this, tan is equal to opposite over adjacent. What's the opposite of this? If this is an eye, it is looking at this. So this is the opposite. So we'll say opposite. So we'll say opposite, which is 12 over. So tan is equal to opposite over adjacent. Well, adjacent is this because this is the hypotenuse, the longest side. So this is the adjacent, which is 5. So this is tan of this. So since I'm saying they asked this and we have found this, now we need to change the sign and this will be equal to this. So this is equal to, we'll say tan ACD is equal to negative 12 over 5, and that will be our case. Then B, find the equation of a straight line passing through the point negative 2 and 3 and is parallel to the straight line whose equation is this. So this is our point, negative 2, 3. This is our equation, 2y minus 3x is equal to 5. What you do, you use this formula, y minus y1 is equal to m, open brackets, x minus x1. Y, so we have this point, so this is x1, this is y1. So y1 is 3, x1 is negative 2. But m is the gradient. So this is how we find the gradient in this case. The other case without the formula, because we don't have both coordinates. So we'll get the equation. We'll use this. Y is equal to mx plus c. This is a standard equation where m is the gradient. So you get to where you make y the subject of the formula, then you follow x, then you take its coefficient, that is going to be the what? The gradient. So in this case, when we make y the subject of the formula, this will be 2y is equal to 5. When we get this negative 3x and take it the other side, it's going to be plus 3x. Actually, it should come first. So we're going to have 2y equal to, but it's same like this, but let's write it like this, 3x plus 5. Yeah. So we need to make y, we'll say over 2 throughout. So y is equal to 3 over 2 x plus 5 over 2. So now see that this looks like this. So our m is our gradient, the one with x. What is with x is 3 over 2. Therefore our m is equal to 3 over 2. So if this is our m, we'll come now to this equation. Y minus y1 is 3 is equal to m is 3 over 2. Open brackets, x minus x1 is negative 2. So this will be our case. And it's going to be y minus 3 being equal to 3 over 2, open brackets, x, negative times negative is positive 2. At this stage now, if you want, you can multiply this with this, or you can say we want to get rid of this, so we multiply by 2 the denominator throughout. So 2 by y would be 2y, then minus 2 times this 3 will be minus 6, being equal to, then these 2 will cancel with this, will remain with 3. 3 by x will be 3x, then 3 by positive 2 will be positive 6. From here now will be 2y is equal to, this is 3x plus 6. When this 6 comes this side, it will be plus 6 also. So we'll say 2y is equal to 3x plus 12. Then we'll say over 2 over 2 over 2 throughout again. So our y will be, this is 3 over 2x plus 12 divided by 2, that's 6. So this is the equation they were looking for. I hope you understand.